Hi folks, I want to give you some background information about this tutorial number 16 that I'm making, which is going to appear in a playlist called Meshing Related Issues in 3D Experience. I'm in the process of making a playlist which consists of doing problems in vibration within 3D Experience platform. And I noticed that one of the problems that I'm interested in to make, actually, let me show you what playlist I'm talking about, is this playlist. This playlist, uh, tutorials 4, 5, 6, and 7, actually is talking about some frame structures. And what I would like to do is replicate tutorial 6, which is a 3-story building, but a solid elements, 3-story frame structure with a solid elements. In order to do that with solid elements, I need some basically preliminary material that is going to be covered in this tutorial 16 and the earlier one that I actually prepared and called it tutorial 15. In tutorial 15, this was modeled as a single part, but made of 3 bodies. And I told you, in fact, I showed you that if you make it as a single part, for example, within the part body, it's going to give you an ugly mesh and it requires some cleaning up. So 15 was actually making it as mesh it as or created as 3 bodies, body 2, body 3, and body 4. And I mentioned that I'm going to come back and repeat this thing as an assembly of parts, assembly of 3 parts, part 1, part 2, part 3. Now, of course, it is true that these parts, they all look alike, and therefore it's foolish to do this part 3 times. So I can make one and then I insert existing component, existing part, so that I save the time of actually making it. Okay, so we're going to assume that this is all made of elastic material, steel. All the geometric effects are off, and this is the dimension of one of these pieces. And notice that when I'm doing it, have an assembly here. It's called skeleton assembly, and it has 3 parts. That's why it's meshed like this. And each one of them is its own solid properties, which are identical, of course. And then we're going to take care of that. Now, we're going to mesh it with sweep meshing. So it's going to give you a very nice mesh that you can see here with these specifications. But what happens, because these are different parts, at the junctures, we have discontinuities, okay? So discontinuities in node numbers. So we have to create tying, tying nodes, basically tie them together. I'm going to use the tie detection exactly like what I did in tutorial 15, automatic tie detection, instead of me telling the software which surfaces are going to be tied together, etc. So pretty much this is what we're going to do. Okay, so let's go ahead to the interface here. Here's the 3D experience interface. So we're going to go to the assembly design, and it's created right there. We're going to insert our first part. So insert new part, which means 3D part. And I'm going to change this thing, the name of it, I'll call it main tube properties. So I'll call it main tube. All right. And there's the reference, main tube. Okay, good. We're going to make it. Double click on 3D shape so that we go into part design. On that vertical plane, I will sketch my cross section. The cross section looks like that. Let's give it dimension 100 by 100. So this is 100, and so is this one. All right, now inside of it, I'll draw a square, 70 by 70. There's some dimensions there. So this is 70. And there is 70 here. And the distance from here to here is 15. And same thing from there to there is 15. So that's going to center basically that middle section. And so what I'm showing you here is actually this diagram. Okay. So exit padded by 1,000 millimeters. So that's my main part. Now, in the slide I mentioned, it's foolish, to make this thing 3 times, because the same thing repeated 3 times. So there are other ways of doing it. For example, you can use multi-instantiation, or you can use existing component, save this thing, use existing component. But I'll do exactly what I said I shouldn't be doing, namely making it 3 times. So right click, insert 3D part. Okay, so now what we do is we go into this part design, and I'm going to drag the pad and dump it in there. So basically, there's the pad. Now they're sitting on top of each other. These two things are sitting on top of each other. For example, you can separate it. Let me use the compass to separate it. Oops. Let me see for a second. Let's do it again. These two parts, there are two parts right now. The original that I made, and this one, they're sitting on top of each other, and you can separate it. For example, you can use the compass in order to do that. I can do it like this. There it is. Okay, let me drag this thing and put it back there. Now, let me make the second part. So I'm going to say go all the way to assembly, right click, insert 3D part. And once again, now I go to the part here, 3D shape, the last one, and take the pad either from the first one or from the second one, and drag it and put it in there. So there's another one. They're sitting on top of each other too. Okay, so once again, I can select this, use the compass, and then move them apart. Okay, and maybe, yeah, that's fine. Maybe move it a little bit. Okay, that we don't need any further. Okay, that's good. All right. So for the rest of the problem, I'm going to assemble these things. By the way, for material, you will see that I'll create the material, but even if I put it on these parts, I will put it on these parts, you will see that I have to go back and do something extra later on. So let me go ahead and actually uh, create the material. This is something that was unusual, but anyway, we'll see. So under tools, find the material. Let's create one. There it is. Create the material. I'll call it February 23, 2024 assembly. Okay, and say okay. And it's right there. Right there. Apply. Oops, actually it was this one. February 23rd, assembly, apply, and close this thing and put it on that. When I try to put it on the part, it won't take it. So I have to do this thing one by one on the parts, basically these parts. So I'll do it like this, and I'll do it like that, and like so, and then say, okay. Now we can go and fill in the material from any one of these. So if I double click on this, I can put in the numbers, and the numbers were already, yeah, right there. 210 gigapascal, 0.3. That was, that's already there. Okay, good. So it's the same thing with these other ones. Yeah, same thing with these other ones. Yeah, good. All right, so now we're going to do the assembly. Let me close these so that I have more space here. Okay. Why don't we actually go to the assembly design? Go to the assembly design. You'll see that this material that I put in there, I have to come back and uh, do it again. Okay. Now, uh, uh, we are in assembly design. Go to the assembly design tab and fix this one first of all. So we're going to go to fix that piece. That's the main piece that I made. Now what we want to do is we want to move this thing to the left, bring it down and move it to the left. Okay, so the different ways of doing it, you can use the compass if you want. So, or you can use this manipulate icon. So let me use the manipulate. So this is a translation. I'm going to translate this thing like that. Okay. And I'm going to turn this thing later on and basically make it vertical, but we can do that later. So under the engineering connection, where's that? Engineering connections, let's do the following: coincidence between that edge and this edge. Good. And I want a distance of 900 millimeter between these two ends. So here is the offset constraint. You click on it between this face and that face, and you put a one a 900 millimeters, and then we say okay. Okay, good. So all right. Now I'm going to put this thing on top of that. So let me rotate this thing first of all using the manipulate. I'm going to use the rotation about this axis, do it like so, and then we go and put it on top of that. So coincidence on the engineering connection, coincidence between this edge and that edge. Say okay. And coincidence between this edge and that last edge. So one more time. Coincidence between this edge. Let me zoom in. Well, I can do that edge and this edge. Doesn't matter. Okay, good. Now, let me just say, just go ahead and proceed, because I just wanted to assemble these things. Some of these constraints may cause a problem when it comes to meshing. So what I'm going to do is I'm going to delete these things. Okay, I'm going to delete all of them. Okay, so delete this, delete that, just in case I run into problems later on. We don't have engineering correction. Because it could be that you leave it there and then it comes back and says that it can't move the stuff. So that's fine. These are good. Okay, so here's the problem. Another problem, but we're going to do the meshing. So how is that done? Make sure you're at the very top, and then you go to the structural model creation, empty FEM, and you get this box which says, look, there are three parts here. Which one of them do you want to participate in the analysis? Well, I want all of them. Okay. All of them to be participating. And then we say, fine. Let me close that. Good. So let's go ahead and mesh it. Mesh, sweep mesh. First one. These are the right parameters, 10 millimeters, 60 layers, mesh. And we get this. Do it again. For that middle one, mesh. Okay. And for the vertical one, mesh, and okay. Now, the properties, we have to put the properties on there. So under properties, here's a solid section. You click on it and you select, for example, you can select the, well, you see, you can do it from this, from the elements right there. We can do that from here. So let me actually do it from there. So let me show you something. Let me try not to use the elements. Try the pad. When you try the pad, correct, it picks the correct material. There's no problem. But let me show you again. If you selected it from here, the mesh, it doesn't know what the material is. So that means we have to go and pick that material from the database. So why don't we make our job easier? Click on it, select the pad from these three pads. Okay, so we can, it's better if you select it from the three, select the right material, do it again from the other pad, because you can't say select any of these. You can do the part body, that's the same thing, by the way. Part body takes the same thing. And finally, for the last one, again, part body, where's the part body? Right here. If you select the mesh, it doesn't recognize, and you have to go and pick it from the database, but that's okay. So it's done. One last thing, I mentioned in tutorial 15 that there are multiple nodes at these locations. For example, let's check it out. First of all, let me update. And then we go to display, click on the numbering visualization. And if you zoom in to this location, if you go from that element, it's 164. If you go from the element above it, it's 5,999. That means that because of the fact that there are duplicate nodes here, what you need to do is to create some kind of a tie between them. And that's exactly what I did in tutorial 15. So first of all, let me hide the mesh so that I don't see it right there. While you're in this structural model creation, you click on the connections, and here is the tie detection. See that? Tie and tie detection. I want the tie detection, and I select the whole model. You can do it based on geometry and then say find ties, and it finds that for you. This is between these two, and this is between these two. And then apply, and then we say okay. Okay, good. So it knows that these nodes above and below, they move together. Okay. All right. So the rest of the stuff is fairly straightforward. We're going to go to the structural scenario creation. Select the finite element model. There we are. Let me hide the mesh. So right click mesh visualization or visibility manager, and don't show me the mesh. And if you don't want to see these purple and yellow, green dots, which represent those tie connection, just on the connection, just click on this so that it hides them if you don't want to see it. Okay, notice that we have to specify the type of procedure that we're going to do. So procedure static, and I'm going to say that everything is linear. So uncheck the include geometric nonlinearity. So basically we're solving a static problem. And then we clamp this end. So under boundary condition, here's the clamp. You select an entire face. It's all clamped now. And then we apply 2,000 pound on the top here. So on the loads, here's the force on that face, downward minus 2,000 pounds. Not pounds, newtons, sorry. Good. So if you don't specify those tying detections and tying constraint, this will fall apart. There's nothing that holds them together, but that will correct it so that this will move as an entire one piece solid model. So let's go to simulation. First one is model and scenario check. Straightforward. This is the simulation check. I just want to point out that depending on how you move these things apart and put it together, there may be some connections created there that is causing a problem. That's why I went to engineering correction and deleted them to avoid that possibility. And that depends on how you have moved things around. Okay, so I think this is done pretty much, and then we're going to run it. Almost done. Remember, we have about 8,000 nodes here. So this is done, and now we're going to run it. This is the simulation step, which is the final running process. And this should agree with the results of tutorial 15 because there I modeled this entire thing, not as an assembly, as a part, but the part had 4 bodies in it. Okay. And I mentioned that you don't have to have 3 bodies in it. And I mentioned that you don't have to do it like that. You can do it all as a single part body, but then the mesh is going to be ugly and it has to be cleaned up before you analyze it. That's why I made a single part, but 3 bodies in it. That's the content of tutorial 15. It's done. Extracting results. There. Close that and look at the second, the second frame, which is going to be the result of the deflection. And this is almost the same result that we got with the single part 3 bodies. All right, folks, good luck.